Hello, boys and girls. This is the course of Environmental Science, and I am G. Chakraborty from Department of Chemistry, welcoming you to this course of Environmental Science.
Now, as I am telling you that this is lecture number 21, that means we have successfully come across the major part, that is 20 lectures of this particular uh, subject. And in this particular course, right, in this 20 lectures, we have successfully completed 3 modules. Now, these 3 modules are namely the general part of the environment, followed by the air and its pollution, which is again followed by water and its pollution. So air, water, we have come across. General part we have completed. Also, we have completed 2 lectures from the land and its pollution part, and this is the part 3. There is a third lecture of land and its pollution module, and the 21st lecture, if as a whole we consider the total syllabus of this course, which is named Environmental Science. Okay, now let us carefully see what we people have studied till now. I'm not going into the details of each and every module, because you know that lecture number 1 to 6 we have studied the general part, consisting of resources, ecosystem, population, environmental management and all. Then lecture number 7 to 13 we have come across air and its pollution, where we have studied the details about different layers of air, as well as we have seen what is acid rain, what is greenhouse effect, what is smog, what are the pollutants of air, right? Several things we have seen. Also, we have seen control of air pollution, right? Methods for control of air pollution. Now, this was followed by lecture 14 to lecture 18, where we people have clearly seen what is water pollution, how water pollution is caused, how we can check water pollution, and what are the different water quality parameters. Okay. After this, there comes the land and its pollution. We have already completed 2 lectures, as I have told you. And in these 2 lectures, we have studied large amount of details about land. Okay, what this large amount of details about land is? First of all, again, we will come to the same phenomenon, that without having proper knowledge about the subject in concern, we cannot say whether there is any problem in that or not. Without knowing the healthy condition of a body, doctor cannot explain whether you are sick or not, right? So similarly, without knowing the proper condition for land, we cannot say whether land is polluted or not. So we have come across the different parts of land. We have seen that basically there are 3 types of soil, not soil, there are basically 3 types of rocks, that is igneous, sedimentary and metamorphic. Now, why we are studying rocks? You may think that why in land part we are studying about rocks. The fact is, in the land part we are studying about rocks because soil is formed by nothing but weathering of rocks. So if soil is formed from rocks, then definitely we need to know details about the rocks, right? So that we people have seen here, we have studied in this lecture, and we have studied what are the 3 divisions of the earth, that is crust, mantle and core, as far as land is considered. And after that we have seen what is solid waste, what is municipal solid waste, that is MSW, what are the 6 steps of present day solid waste management, that is collection, then storage, then transportation, recycling, treatment and disposal, right? These are 6 steps of the modern day solid waste management that should be practiced. So these things we have come across, right? Also we have seen what are the different types of solid waste, right? Agricultural waste, domestic waste, industrial waste, biomedical waste, hazardous waste, e-waste, right? We have seen that, the different types. Okay, after that, this was the first lecture. After that we have seen in the second lecture that what are the methods of waste disposal, right? This is also very, very important for us, because waste cannot be left as it is, should be disposed in a proper way so that it is not harming the environment and the people who are living inside that particular environment. Okay. Now, how we can do it? We can do it in a very simple way. There are few methods that we practically use. One is open dumping, which is not a good method. another is landfill, which is comparatively good method, then comes incineration, and finally composting, right? Now in this composting, incineration and all, what we people basically are having, we are having several things like what are the advantages, what are disadvantages, what are the different parts, how the process is done. So these things we have briefly explained with diagram, right? Now the question arises, if these were the facts of the last two lectures of land, what will be the facts of the next two lecture? Means this one and the next one. So next one we'll see in the next one, but here we'll see what is present in the next lecture. Oh, sorry, what is present in this lecture, right? So lecture number 21, land and its pollution, part 3. And the lecture highlight contains hazardous waste, characteristics of hazardous waste, classification of hazardous waste and their effects. This is followed by radioactive waste and radioactive waste management. Okay, so two different type of waste will be discussed in brief in this particular lecture. We are going to see how we can manage this particular waste. So let's go. As you can see, our first and foremost topic is hazardous waste. So you can see it large in front of your screen, and this is the basic symbol of hazardous waste, right? Now what is a hazard? What is the meaning of the word hazard? Hazard means something which will create problem to us, right? We say health hazard means something which will create problem to our health. We'll see natural hazard, so nature has created some problem to us. We'll see biohazard, so biological items have created a problem. See, just like COVID-19 virus, the spread of outbreak of COVID-19 virus is nothing but a biohazard. Why? Because this particular virus is a biological organism, right? And its spread has resulted in biohazard, right? So let us see how we can predict whether a waste is hazardous or not. See, caution is very much important for hazardous waste, and here we are going to see that what hazardous waste means. But remember, we have to be very, very cautious because we are studying hazardous waste. I'm just joking, okay? Online we need not be cautious, but offline, whenever we are working with hazardous waste, definitely 100% caution is required, okay? And this caution has nothing to do with caution money, okay? So hazardous waste can be defined as the waste or combination of waste which pose substantial threat to human health and environment, right? I have done a beautifully straight line. You can see hazardous waste, basically what the definition says, the waste or combination of waste which pose substantial threat to human life and environment, okay? If any waste is creating problem to us, to our health and environment, there is hazardous waste. Universe of hazardous waste is large and diverse. Hazardous waste can be liquid, solid or contained gases, right? So hazardous waste is a big thing, is a big category, and may contain three types. One is liquid hazardous waste, another is solid hazardous waste, third one is gaseous hazardous waste, okay? And they can be byproducts of manufacturing processes, discarded used materials, or discarded unused commercial products such as cleaning fluids, solvents, pesticides, etc. So they can be either byproducts or used materials or unused materials, right? Means suppose you are what I can say, making a table. Wood is not wood is not a hazardous waste, but let us imagine you are making a table, okay? Now for making that table, there will be some byproduct which will not be needed, and there will be some unused material, and there will be some used material. Used material means, suppose the container of the varnish that you will apply on your table, that particular container is a used material, okay? Right? Similarly, the what I can say, the layers of wood that will come after you work on that particular table, right? That is unused material, okay? So though wood is not a hazardous waste, just I'm giving that example to you, okay? So the following paragraphs will provide an overview to the various ways that a waste may be identified as hazardous waste. Yes, this is very important for us, because by simply seeing the waste we cannot say whether it is hazardous or not. So we have to be very careful, and we have to see that whatever waste we are dealing with is hazardous or not. How we are going to do that is explained in the next slide. So let us go to the next slide. Now as you can see, this slide is very important, and it will discuss the characteristics of hazardous waste. So let us choose a good color, just like let us select blue. Okay, so characteristics of hazardous waste we'll study in this particular slide. You can see there are 4 characteristics. Now what these 4 characteristics are: number 1 will be ignitability, right? Ignitability means the ability to catch fire. So ignitable waste can create fires under certain conditions. They can undergo spontaneous combustion or have a flash point less than 60 degrees Celsius. Example include waste oil and used solvents. Suppose you are having methanol or ethanol, right? So it is highly applicable for this particular thing. Ignitability is the ability of a waste to catch fire very easily, right? They are also called flammability. Okay. Number 2 is corrosivity. Let's see what corrosivity means. Corrosive waste are materials including solids, fatty acids or bases, or that produce acid or alkaline solution. Right. Aqueous waste, the pH less than or equal to 2 or greater than or equal to 12.5 are corrosive. Liquid waste may also be corrosive if it is able to corrode metal containers such as storage tanks, drums and barrels. Paint battery acid is an example. See, so corrosive waste are those waste which basically corrodes any articles, right? Maybe solid, maybe liquid, right? For example, if you use an iron container to store sodium hypochlorite, then what will happen? It will get corroded. Okay, right? So basically that particular thing is corrosive for this particular item. So here one study is given that if the pH is less than 2, that means strongly acidic solution, or if pH is greater than 12.5, that is strongly basic solution, then they will be corrosive in nature. Okay, so this was all about the second point, which was corrosivity, right? Now here comes the third point, that is reactivity. What does reactivity means? Reactive waste are unstable under normal condition. They can cause explosion or release toxic fumes, gases or vapors when heated, compressed or mixed with water. Examples are lithium sulfur batteries and unused explosives. Right? Reactivity is something which, by virtue of which, a chemical compound will react very fast. This reaction may lead to an explosion or some problem, right? Release of any toxic fumes or all. So some examples were lithium sulfur batteries and unused explosives that have been given, right? Reactivity is also an important parameter here. Last but not least is the toxicity. So 4 parameters are there. Okay, toxic waste are harmful or fatal when ingested or absorbed, right? So if you eat it, it will be harmful to us. When toxic waste are disposed, toxic constituents may leach from the waste and pollute groundwater. In the last lecture, we have studied about landfill and open dumping. We have discussed briefly that one of the major problems of these 2 methods, right? Because in these 2 methods, solid waste are dumped inside the land, right? They're buried inside the land or are just left over the land. So basically, the problem is that whenever you are applying huge amount of waste on land, then what will happen? It may happen that the waste are penetrating inside the soil and they are polluting the groundwater. But this is of this may have a very dangerous impact if this is not controlled, right? So same thing is happening here as toxic waste, that they're harmful or fatal when eaten, right? If eaten means if they go inside, it is not like that one toxic waste will be kept on plate and you will eat it out or I will eat it out. It's not like that. Okay, basically they comes along with food. For example, DDT enters food chain, we know that, by agricultural chemicals, right? Same thing happened for mercury in the Minamata disease, right? So whenever these particular substances are exposed, then what will happen? They will leach from the groundwater and they will pollute it out. So this is very important to be careful. Okay, let's see what next. Now hazardous waste can be of 3 types. Okay, hazardous waste can be of 3 types. You can see different type of articles are given, right? This PPT is looking very good. This hazardous waste may be of 3 types as far our knowledge goes. Number 1 is the radioactive waste. Number 2 is the biomedical waste. number 3 is chemical waste, of which radioactive waste we will discuss in this particular lecture, right? And the others we'll discuss in the upcoming lectures, okay? Right? So let us move to the radioactive waste. See, here it is briefly explained what radioactive waste are. So these are the type of waste that contains radioactive materials and is usually a byproduct of nuclear power generation and other applications of nuclear fission or nuclear technology such as research and medicine. See, first we need to know what is radioactivity, how radioactivity is caused, means under what conditions an element will be radioactive. This is a prerequisite knowledge, it is required, it is very, very important. So tell me, under what conditions an element will be radioactive? It is again class 11 level chemistry, so you should know it. Under what conditions an element becomes radioactive? Hydrogen has 3 isotopes, right? One is protium, another is deuterium, third one is tritium. Of these 3 isotopes, protium contains only proton, deuterium contains 1 neutron, 1 proton, and tritium contains 2 neutron, 1 proton. This makes tritium radioactive. Again, C12, C14, C14. C12 is normal carbon, non-radioactive. C13 again is non-radioactive, but C14 is radioactive. Now, C14 contains 8 neutrons and 6 protons, right? Now what does it imply from this particular examples? The very simple thing is, if we consider the construction of an atom, if the amount of if the number of neutrons in an atom is more than 1.5%, sorry, 150%, I'll say, to the number of protons present, then the element will be radioactive. Means for every 100 protons, if there are 150 neutrons, then what will happen? Or more than that, what will happen? The element will be radioactive, right? And it will show some radioactivity nature, okay? Now as you can see, radioactive waste are the type of materials that contains radioactive material. Suppose we are working with some radioactive species. Now whatever waste will be generated from that particular thing will be radioactive waste, and it is usually byproduct of nuclear power generation. You know, nuclear power generation is very important nowadays, and nuclear power is something about which every country is talking about, right? So due to this nuclear power generation, whatever waste will be there, that will be radioactive waste, and also it may result from nuclear fission, nuclear technology such as research and medicine, okay? Right, so this was the definition of radioactive waste.